All right, guys, I'm here to get you started on your getting connected activity. So you just finished up watching a video about ionic formula writing, which we kind of covered last week after your quiz with the notes on the board. And then I also introduced in that video compound naming. And so what we're going to do is some practice with that. So remember, just like I showed you guys last week, the back of your periodic table is going to be very helpful with this when we're trying to figure out how many, the charge of each of the ions. So look on your back of your periodic table at the periodic table of ions, and that will help you with the charge of the elements that we're going to have here and here. Okay, charge of element 1 and charge of element 2. So look again on back of the periodic table. Okay. All right, so let's take a look at the first one. So we're going to hook up sodium, which is a metal, with fluorine, which is a nonmetal. So sodium is in group 1A, and so he's got one valence electron. If we look at the back of the periodic table, we can see that sodium is going to have a +1 charge, right? So he's got one valence electron. He's on that weak side with very low attraction and low ionization energy. So he's going to lose that electron and become a +1 charge. When we hook him up with a nonmetal like fluorine, who's on that right side of the periodic table, who's very strong and attractive, he's going to be gaining electrons. So if we look on the periodic table, fluorine has 7 valence electrons. He's in group 7A, and so he's got 7 valence electrons. He only needs one more to make his valence shell full with 8. And so he's going to grab one and then become a -1 charge. So you can, again, find that on the back of your periodic table. You can look at fluorine, it'll say negative or -1. All right, so when we take a look at the charges for metals and nonmetals, remember when you make a compound, the compound has to be neutral. That means the charges need to cancel out. So in this case, a +1 does cancel out a -1, right? If you add them together, they legit make 0. And so all we need to do is hook up one Na and one F to make this compound NaF. Okay. So if the charges cancel right away, then you don't need a crisscross or anything that we talked about in the video or the notes. Just put, one of each together, smack them together, and there's your neutral compound. Okay. Now remember, and you can see on the board too, we've got the name of the compound. So if we look at Na on the periodic table, its name is sodium. If we look up F, his name is fluorine, and then we just change that ending to IDE. So instead of fluorine, we make it fluoride. Okay. All right, so let's go over 2 more, and then I will give you some time to finish up the rest on your own, and then the sub will show you some answers towards the end of class. All right, the next one that we're going to do together is down here, Ga and O. Okay, so this guy here, Ga hooking up with O. So gallium is found in column 3A, so that means he's got 3 valence electrons. When he's on the weak side, remember left-hand side with the metals is very weak, Coulombic attraction and low electronegativity and ionization energy, so he's going to lose those 3 electrons, become a +3 charge. Again, you can look at the back of the periodic table at your ions and see that gallium is going to have a +3 charge. Now, when we hook him up with oxygen, oxygen is in group 6A, so that means he has 6 valence electrons, right? And he's on the strong attractive side, so he's going to be gaining or grabbing electrons from other atoms in order to fill his valence shell with 8. Now, to do that, he has to grab 2 more, and so his charge is going to be -2. Again, verify that on the back of your periodic table where you can see the periodic table of ions. Okay, so this time we can see that we've got a +3 and a -2, and those do not add up to 0. They do not cancel each other out. So the net charge there is a +1, and we cannot have a net charge. It has to be neutral. So in order to figure this out, okay, we need to crisscross the charges. So what that means is we're going to take the 3 from the charge in gallium and we're going to put it by the feet of oxygen, and then we're going to take this 2, okay, and we're going to put it down by gallium. So in essence, what we're doing is, let's just do it up here, Ga plus 3, and we've got an O minus 2, and so we're going to take this 2 and we're going to put it down by the feet by gallium, and this 3 is going to go down by the feet of oxygen. And what that means is that we need 2 atoms of gallium and 3 atoms of oxygen to come together to steal each other's electrons to make everything neutral. So in this compound formula, we're going to have Ga2O3. Okay, so again, that came from just switching up the charges here that we see in this example. We looked at the charges on the back of your periodic table, okay, on the ions, and then because they did not add up to 0, we just took the numbers and we switched it. When you switch it, there's no negatives, okay? That negative disappears, goes away, because we need to have a positive number of atoms in the molecules. There's no such thing as having a negative number of atoms in a molecule. It just wouldn't exist in the molecule, so we wouldn't write it down. So it becomes, all of these subscripts become positive when we crisscross those charges. All right, last but not least, we're going to name it. So if we look up Ga on our periodic table, we're going to see his name is gallium. And if we look up oxygen, okay, that's oxygen, and we're going to change that ending to IDE. So we're going to make it oxide instead. So gallium oxide. All right, the last one we're going to go over is the very last one here. So we already did gallium, and we said gallium has a +3 charge. Okay, and now we're going to hook them up with a polyatomic ion. And you can see those guys are on the back of your periodic table as well, in that chart, right above the ions. Excuse me. So we're going to see those polyatomic ion charges on that back side. And when we look up nitrate, okay, NO3, it's going to say a -1 charge. Okay, so gallium has a +3 charge, and nitrate has a -1 charge. And so again, do they add up to 0? No, they don't. So we're going to take this 3 and we're going to put it at the feet of nitrate. And when we do that, we put it on the outside of the parentheses, just like I went over last Friday and in the video as well. And so we're going to crisscross that 1 over by gallium. And so our formula is going to be GaNO3 in parentheses, and then a 3 on the outside of the parentheses. Okay, so that's an N. So GaNO3 in parentheses, and then 3 on the outside. And remember, that comes from the charge on gallium here. So that 3 goes on the outside of the parentheses. What that means is that we need 3 molecules of NO3 in order to cancel out 1 atom of gallium. Okay, so we need 3 nitrate molecules to grab the 3 valence electrons that gallium is going to be giving away. Okay, so that's going to be our neutral formula for this one here. Now the very last thing we need to do is name it. So here, Ga again is gallium. All right, and then when we are working with polyatomic ions, remember from the rules of our notes, we do not change the name to IDE. So we just look at the name of the polyatomic ion and we write it down. So NO3 is nitrate, and so it's just gallium nitrate, just like that. Okay. All right, so you guys go ahead and finish this up, and then in about 15-20 minutes, the sub will pop up the answer key on the screen in the back. And if you do have any questions, if you need any help, please come see me tomorrow, 7 a.m. Or at break or your lunch for any help that you need with figuring this out. Or you can come tomorrow after school as well for some tutoring after school in S213.